So what you're saying is that you're going to take this class right here, add it together, and divide it by 2.
So that's for all of them going straight.
Exactly. So what are you going to put here?
102.
Right. And what's the next one's going to be?
107.
Do the calculation. Do the other one. Keep going. Right.
Mm-hmm.
Go ahead.
7.
Go ahead.
1 and 1.
Very low, right?
Mm-hmm.
You see it? That's how you plot. Now, what does the author do? The author connects these points, right?
Mm-hmm.
So there's a connection going on here. It goes up, comes down, and doubles down. Doubles down. You see
Then I
it?
go over.
She go with some more. Oh, 132? What was 132?
1.
Oh, okay, very good. Thanks for that observation. All right. So you see how you see how it looks. Now, can you actually see this graphically, given the data? Okay. See, yeah, we have a question here.
Okay, so correct me if I'm wrong. So now I'm starting to get the frequency. Basically, it's just whatever you make up, and you have to just match it. Like whatever you put down there, like you make up whatever numbers here, and then you just divide it by 2, which is the midpoints, and then frequency is just arbitrary. The highest number didn't necessarily have to be 18. It could have probably been 16 or maybe 20.
Yeah. All right. If it was a different expression. All right. You got it. You got it, brother. You got it. Yes.
I have a question about the, I understand just
Yeah,
the
speak up.
midpoint, just the midpoints
Yes.
and the frequency.
Yes.
Meaning that, okay, the midpoint you get by dividing by 2, but like for example, where it says 102 and it says frequency 2, that doesn't mean that there's 102 shows up 2 times. That doesn't mean that, right?
It will never show up 2 times.
Right. That's what I mean. That it has nothing to do with that.
No, it doesn't. Because you were looking at this. Right? What do we call this before? Class width, class size?
Right.
Boundaries?
Yeah.
Exactly. They all mean the same. All right? These are unique. Right? But we're looking at it at a different scale here. Now, it's not the 99.5 to 104. When we average it out, we want a good, clean number, a whole number. It's just a different way of looking at it. And it's called frequency polygon. Right? Isn't this what this graph is?
Yes.
It sounded kind of complicated when we first was introduced to it, right? What the heck is that? But you get it through practice. All right? Now, what is the last one that begins with an O?
Ogive.
Ogive. O-G-I-V-E. Now, you think you had problems before? Buckle your seatbelts.
Right, I'm getting in the car and keep worrying the money in.
Now, let me ask you something. Now, should I give you that as an assignment right now? Then take a survey of the class and see how many people say yes or no.
Yes, let's do that.
That's a good example, right?
Yes.
Okay, everybody say yes. Raise your hands. You'll take the water.
No.
Hold on, be honest. Okay, what we got? 1, 2, 3.
I'm not dying next to my money.
5, 6, 7. Write that down. 7 people take the water. How many people will take the $1 million? 1, 2. You can't raise your hand twice. That'd be cheating on it. No, what I'm saying, that can happen in the data, right? You could double dip in the data. 1, 2, 3, 4, 5.
Kim, why you raising your hand?
6. 6 people said the $1 million. How many people did not vote? Undecided. Right, undecided. 1 and 2. You didn't
So you
vote.
voted already.
Did you vote?
Oh, okay.
You're right. You're right. But for noticing that, that would be double dipping. So 3 people says no. Count the sample size in the class. How many people are in here, excluding me? How many people? Sean, look around. How many people are here? Tell me. No, you counted him twice.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
What's the population? Sample space.
16.
What's wrong? That's what I'm talking about.
Six that wanted the million and 2 that was undecided, so that's only 3.
No, it
Count
was
again.
3. It
You're
was
not
3
counting
that's
me?
undecided because she said she didn't vote.
Oh, 3?
You voted or didn't vote?
2. She did not
Undecided.
vote.
Okay, so it's 3.
It adds up.
How many people say undecided?
3.
Raise your hands.
It's 16 people.
Be consistent.
Yeah, that's right.
You can't understand? Did he count right?
It's 16 people. Oh, I didn't see her. I didn't see her behind
Did he
him.
count right?
Did you see her behind
Did you
him?
count right? What?
No, I wasn't counting you just now.
16.
Yeah, so it's right.
We're good. All right, so,
Why are you moving?
hold on, we gotta move on this. Let me ask you something.
You know you mixed me up.
Let me ask you something. Do it quick. What is the, tally it up? What's the, relative frequency of the people that says water? Give me a percentage.
How many people said water? 7.
How many people?
What's the percentage? And then the
What's
next
the-
one, you give me the number
44%.
of people that said $1 million.
I need the number for the people.
Million? How many said $1 million? 6.
And it's 17 people?
Well, 16
44%.
sample spaces.
It's 16. Oh,
Yeah.
okay. 16 and 7 people.
Exactly. You good?
37.
There you go. All right.
Hi, Sherry King. Okay, so this is, what's this called?
Summation.
A summation,
Sign.
and it goes from 0 to 6, and I use S as the variable
That's
letter.
right.
So my equation is 5 times whatever S is plus 13. So you make the chart and you use the same digits that you use for your summation from 0 to 6 on one side. Then you put your equation in the middle, and then you make another column for the result.
So that would be your expression as well, right? So you're saying equation is the same as
It's
expression?
expression, yes,
All
it's
right.
the same.
Okay.
So then you, for each column underneath your expression, you fill in the variable with the appropriate number.
Or you substitute, right? And because it's changing.
Substitute,
Yes. Okay.
So 5 times 0, because 0 is the number, plus 13, and you just fill it in each way. And then once you get all the results in, then you tally up all the results and total it on the bottom, which will give you 196.
Very good.
Hi, my name is Theopolis Conley. I am in math, anxiety, and statistics here at the School of College of New Rochelle. We are with our professor, Mr. O. McAllister.
Yes.
Brilliant teacher, by the way.
Thank you.
Okay, today we're discussing how to find the statistics of random or possibility. We asked the basic question of 10 people, do they own a cell phone? The sample that we're working with is the 10 here, because that's how many people we're going to speak to, and the relativity is the question of whether or not they own a cell phone, and there's only 2 answers to the question, yes or no. By graphing everything, you get to see the actual data as we're compiling it, and we have how many people we spoke to. You have the list 10. The actual question and direction is the cell phone, whether it's yes or no. Our answers must match the 10 people that we spoke to directly. Once we figure how many people we spoke to, we're looking at the frequency of the answer to the question. Yes happens to be the highest frequency in this case because 7 people out of the 10 answered yes that they own a cell phone. 1, 2, 3, 4, 5, 6, 7. Oops, I'm missing. Oh, 7, right. 7 people answered yes, and then out of the other 3 people that was left, 3 answered no. So 3 and 7 equals our sample space, which is 10. So now we know that we're working with a number of 10 out of. As we go over to here, we're looking at the relative frequency of the information. So now we're going to look at it in a percentile form where the 7 who answered yes over the 10 sample question multiplied by 100% gives us 700 over 10, which also brings us to 70% who have answered this question with the answer of yes. We also do the same thing with the sampling of the no. We have the 3 out of the 10 times 100, which gives us 300 over 10, which gives us 30% of people who answered the question know that they do not own a cell phone. Then if we want to show a little bit further into what we want to look at, we draw a pie chart. Out of the pie charts are usually based in 4 quarters. So we're going to look at it as 25 plus about 5% more to give us that 30. And that area is shaded a different way. And what's left out of the 30 is the 70%. And that's shaded also a different way to show you the difference between the two. Now, the pie chart, and it all equals 100% at the end. Okay. Now, we have a bar graph here which shows the exact same information but in a different way of statistically showing it. We have all the yeses that equal about 70%, so we're going to go somewhere a little bit above the 50 but below the 75 so that it doesn't get too close, and mark it off as 70% for the yes. Same thing goes for the no. We're about 30%, so it's a little bit above the 25, about right there, and we draw a line and we bring our bars down, and they both still total 100% as far as the bar graph. Okay. Now we're going to look at expressions. And in this equation, we have our sigma sign and our index is set at 0. Our expression, the secondary number that we're going to go up to is 4. So our expression is between the index of 0 and 4. Now our expression itself is 6 times index plus 3. So as we graph it, we first bring down the information, 0, 1, 2, 3, and 4. In the index column, we substitute the I with the number that is actually represented. So you got 6 times 0 plus 3. 6 times 0 is 0 plus 3 equals 3. 6 times 1 is 6 plus 3 equals 9. 6 times 2 is 12 plus 3 equals 15. 6 times 2. 6 times 3 is 18 plus 3 is 21. 6 times 4 is 24 plus 3 equals 27. Oops, I forgot one major part. You must add the accumulative at the bottom. So that's 48, 49, 50, 51, 60. Wait, am I doing this
So you got 9, 3, 12, 12, 5, 17, 18, 25. Put the 5, carry the 2.
Yeah.
All right, there you go. 2 plus 1.
4, 6, 7.
7. So that's your cumulative frequency.
It's 75.
Yeah, so that's your cum, right? So the sigma sign is what? Summation.
Summation. Yes.
Okay, you're going from I equals 0 to 4 in that expression. You do substitution, and you get a final total.
Correct.
Thank you very much. And what's your name?
Theopolis Conway.
Very good. Very good. Very good.